So first thing is introduction. So in this introduction, இப்போ பார்த்தீங்க அப்படின்னா நம்மளதுல that matter you know that amount of space occupied by the body, the amount of matter contained in a body is called mass னு சொல்லுவோம். அதே மாதிரி space occupies, that place occupies and a space is called matter. So some space is occupied by the matter is called matter, that is called matter. So here that matter is classified into three types: solids, liquids and gas. And you know the difference between the solid, liquid and gases. Now we are using so many things in the solid form and liquid form and the gas state. So for example, we can take the water, petrol. These are all the things are example for the liquids. Then solids. Solids can take that any metal and solid or this stone, like that you can take any example for the solid. And gases, you know the different type of gases. Okay. And the solid, liquid and gases are the different physical and chemical properties. Okay. And we can, it has the different chemical and the physical properties. In lower class, we studied the different properties of the solid, liquid and gases. Now, when an object is divided, ஒரு ஆப்ஜெக்ட் இருக்கு, அதை நம்ம சின்னதா உடச்சிட்டே போறோம். சாலிடா இருக்கட்டும், அதை சின்னதா பிரிச்சுட்டே போறோம். So we can divide it many times, and finally we will get one small piece that is called speck. That is, we can't divide it in one more time. அதுக்கு மேல நம்ம அதை டிவைட் பண்ணவே முடியாது. That's called atom. That's the name of that small speck is called atom. Atom is a Greek word. The Greek word that means without division or indivisible. That's called atom. Indivisible or without division or indivisible. The size of an atom is very, very small. The size of an atom is 10 to the power of minus 10 meter. So you know that 10 to the power of minus 10 meter already we call it as Armstrong. 10 to the power of minus 10 meter. An American physicist, Richard P. Feynman, and then he explained that suppose you are consider that atom that's very, very small compared to the apple. So you can take that thing to think atom and apple. So apple is very bigger than that atom. Suppose you are consider that atom, size of an atom is equal to the size of an apple. So here the atom is considered as the size of an apple. So the size of an apple is equal to that earth. So there is a difference between the size of that atom and that apple. So you can consider that the size of an apple is an atom. Then size of an apple atom is apple. Size of an apple is earth. So compare the two sizes, you can know the size of an atom is very, very small, 10 to the power of minus 10 meter. And that theoretical models. Initially, that different scientists are explaining the theoretical model. The first person, the first scientist, J.J. Thomson, first he explained that he conducted the many experiments about the atom, and he first started the atom model. Then after that, J.J. Thomson, Rutherford. After that, Rutherford, that the next person is Rutherford. Niels Bohr. So different scientists are suggested different theories in a different time periods. Before 930, they thought that only atom is there. After 1930, the scientists have discovered the proton and the neutron. So electron and proton are the fundamental particles of the atom after 1930. Before that, they consider only that atom, it is made up of negative particles. After discovering of the proton and neutron, there are so many elementary particles are inside the atom. After that 1960, that proton and neutron is not a single particle. That proton and neutron is made up of small particles that's called elementary particles, quarks. So these are all the things in this lesson you are going to see that. The next thing is, in this lesson we are going to study the structure of the atom. Then the property of the atom. And how the nuclear energy is produced. What is meant by nuclear fission and diffusion? These are the things we are going to see in this lesson. Okay. Next thing is electric discharge through gases. Electric discharge through gas. So you can see the picture on the screen. Electric discharge through a gas. It's a glass. It's a discharge tube. It's made up of glass. The size of the glass is 50 centimeter. The length of the glass is 50 centimeter and the diameter is 4 centimeter. And the glass is connected to the vacuum pump. So the vacuum pump used to remove the gas inside the glass tube. And two ends of the glass tube have the two electrodes. That one end is, you know that it is connected to the negative terminal. That another one end is connected to the positive terminal. The terminal which is connected to the negative terminal is called the cathode. The terminal that is electrode is connected to the positive terminal is called the anode. So this is a tube. And the potential difference between the tube is applied between the two tubes is 50 kilovolt. That means 50,000 volt. So very high potential difference is applied between these two electrodes. That is cathode of the electrode. So very high potential, 50,000 kilovolt. So you know that electric field is applied, the potential is applied very high means definitely the electrons are accelerated. Okay, so this is the electric discharge tube in a schematic diagram. So this cathode and anode and negative and positive terminals are there. High potential difference that is 50 kilovolt is applied between the negative and positive terminal. And gas is filled inside. So it's a vacuum pump is here connected to the glass tube. Okay, right. So here, negative and positive terminal is connected here. Then that pressure of the glass tube is decreases by using the vacuum pump. Initial, that pressure is 110 mm of mercury. So mm of mercury is the unit for the pressure. So initially the pressure is decreases 110 mm of mercury. There is no change inside that tube. That means that glass tube. Again the pressure is decreases up to 100 mm of mercury. That 100 mm of mercury means there is a spark. There is a spark produced between the irregular streaks. That irregular streak means it is not a continuous light. It is irregular streaks produced between the cathode and the anode. Okay. So irregular streaks means that we are from here cathode to anode. That irregular streaks like that. That dotted line like that. That streaks are produced from cathode to anode. Again, the pressure is decreases up to 10 mm of mercury. The pressure is decreases 10 mm of mercury. When pressure is decreases 10 mm of mercury, a continuous luminous light is produced from the anode to cathode. From here to here, that anode column, that's called anode column, is produced between the anode and the cathode. So it's produced between the anode and cathode with the pressure of 100 mm of mercury. Then that pressure is decreases between anode and cathode is 0.01 mm of mercury. So when it decreases 0.01 mm of mercury, so that is the light between the anode to cathode is invisible. That is invisible. Then a dark place is produced between the anode and the cathode. That dark space is called Crookes dark space. Crookes is the name of the scientist. So we call it Crookes dark space between the anode and the cathode. After that, that glass is here. The glass is completely converted to the color of green color. Green color is produced by the green color fluorescence produced on the screen. That not screen, that glass. So some invisible light rays are emitted from the cathode. That light rays are produced the green color of the screen, the glass tube. So that explains that some invisible rays are emitted from the cathode. ஏதோ கண்ணுக்கு தெரியாத ஒரு லைட் வந்து கேத்தோட்ல இருந்து எமிட் ஆச்சு. எமிட் ஆனதுனால தான் என்ன ஆகுது? That colors are produced. The pressure is 0.01 0.01 m of mercury. Okay, so this is called the cathode. That ray which is emitted from the cathode. Cathode no ray emitted, that ray is called electron, or that is cathode ray. Cathode ray is nothing but electron because it is emitted from the negative terminal. So it is called the electron. Right. Now we are going to see the properties of the cathode rays. What is the properties of the cathode rays? The cathode rays possess energy and momentum. Energy and momentum. I told you that it is nothing but electron. You know that electron has mass and it travels with the velocity of v. So definitely it has the energy and momentum. It is travel with the velocity of 10 to the power of 7 meter per second. So the velocity is 10 to the power of 7 meter per second. You know that velocity of light. Velocity of light is 3 into 10 to the power of 8 meter per second. So the velocity of electron is 10 to the power of 7 meter per second. So light has no mass, so it is traveling in a very greater speed. But that electron has small mass, small amount of mass. So it is traveling with the velocity of 10 to the power of 7 meter per second. And the electrons, that is cathode rays, are reflected by the electric field and the magnetic field. Why it is deflected? Because that electron is a negatively charged particle. It's a charged particle. Charged particle means definitely it will deflected by the electric field and the magnetic field. And the deflection of that cathode ray indicates that it is negatively charged. Because cathode rays எங்கேயாவது pass பண்ணீங்க அப்படின்னா, for example, you are applying the electric field. Positive or negative electrodes are there. Suppose you are passing through the cathode between that electrode, that cathode ray is deflected towards the positive electrode. So this indicates that cathode ray is a negatively charged particle. When cathode rays are allowed to fall on the matter, any material or the matter, it will produce the heat energy. So எங்கேயாவது electron வந்து விழுந்துச்சு அப்படின்னா என்ன ஆகும்? It will produce the heat energy. And they affect the photographic plate. So photographic plate, you know that the X-ray எடுக்கும்போது பார்த்துருப்பீங்க ஒரு photographic plate. So the electrons are affect the photographic plate and it produces the fluorescence. Fluorescence means it's a luminous light. It emits the light. That is fluorescent, glittering. அப்போ என்னன்னா இப்ப நான் சொன்னேன் that the light invisible rays are emitted from the cathode rays. That cathode ray emitting invisible rays are produce the green color on the glass tube. That glass tube is by producing the fluorescence. Fluorescence na ஒளிர்றதுன்னு சொல்லுவாங்க தமிழ். Okay, it's called fluorescence. So it is producing, it has the property of the material produce the fluorescence. Then cathode rays falls on the high atomic mass material. It produces the X-rays. And 7th lesson la பார்த்தோம் production of X-rays. When fast moving electrons are suddenly stopped by the metal target, electrons are produced. So X-rays are produced, not electron. X-rays are produced. So fast moving electrons are suddenly stopped by the metal target. X-rays are produced. So the electrons are passed on the metal means definitely the X-rays are produced. Then the cathode rays are ionize the gas which they pass. So cathode ray pass from the it has the property of to ionize the gas. Then the last thing, the speed of the cathode rays is up to 1/10th of the speed of the light. Because it is a 1/10th of the speed of the light. Why it is not equal to the speed of the light? Because it has the small amount of mass. But light has no mass. It is traveling with a greater speed. But electron has small amount of mass. That's why it is traveling with the velocity of 1/10th of the velocity of light. Okay.